This is a transparent view of the disengager and regenerator. The disengager is at the top. The regenerator is below. To the left is the feed riser duct. These are the three main vessels used to turn crude oil feed into a vapor. The vapor is used to make gasoline and other petroleum products in a refinery FCC unit. A vapor is produced when 1350-degree catalyst comes in contact with 650-degree crude oil. The function of the disengager is to separate the crude vapor from the catalyst. The two functions of the regenerator are to burn off the hydrocarbons that have attached to the catalyst and to separate the resulting flue gas from the catalyst. In the lower section of the riser, there are multiple nozzles where crude oil feed is introduced. This very hot crude feed is mixed with a high volume of hot 1350-degree catalyst that comes from the overflow well in the regenerator. The risers in some FCC units transport as much as 70 tons per minute of catalyst. Catalyst looks like a fine white sand, but it is made from multiple exotic metals that can withstand high temperatures encountered in the process. This mixture travels up the riser, and by the time it gets to the top, the crude feed has transformed into a vapor, containing all the chemical components necessary to make petroleum products like motor oil, diesel, and gasoline. At this point, the catalyst needs to be separated from the vapor. The crossover from the riser penetrates the shell of the disengager and is attached directly to the inlet of the first stage cyclones. The first cut of vapor and catalyst happens here. The lighter vapor and a small amount of catalyst fines exits the top of the cyclone, and the heavier catalyst drops down through the cyclone and dip legs to the bottom of the disengager vessel. The vapor and some fine particles of catalyst, now in the top of the disengager vessel, makes its way to the inlets of the second stage cyclones. They are on the opposite side of the vessel. The second stage cyclones remove most of the small particles of catalyst. At this point, the vapor exits the top of the second stage directly into the internal plenum, which is attached to the top head of the disengager. The vapor product goes out the top of the disengager and travels to the fractionator vessel. The fractionator, not shown in this model, separates the vapor into its individual components. The catalyst from the bottom of the cyclones travels down through the regenerator via a long pipe and is deposited just above the air grid. The air coming out of the air grid nozzles aerates the hot catalyst. The cleaning process involves subjecting the catalyst to intense heat, 1350 degrees, to burn off any carbon buildup attached to the particles. The flue gas from this process is separated from the catalyst through another two-stage cyclone system. And the catalyst dropping out of the cyclone settles on the air grid affected area. Eventually, the catalyst makes its way to the top of the overflow well and falls down through the bottom of the regenerator. At this point, the catalyst and crude oil transfer process begins again.